reference tooth that we originally set up for use with a pin gauge.
Now, for a raker to function efficiently, the trailing surface of the raker tip needs to have a sloping clearance angle. This enables the raker to penetrate the wood and not ride on top like a sled. Now, this is accomplished automatically with a sloped filing plate. However, if a flat filing plate gauge is used, the clearance angle needs to be established by carefully dressing the horizontal surface left by the file so that it slopes, providing a clearance angle. Care needs to be taken when you do this so that the raker tip is not over-filed, which would result in a shortened raker.
Okay, the next tool we're going to adjust is the spider. The spider is used to measure the set on the tooth. It's a fairly straightforward process. You have basically a flat surface that you use as a reference. You put the spider on the flat surface, and the spider should rock around the short legs between this long legs here so that you can see it rocking this way. And the adjustment on a spider is accomplished by changing the space between the tip of the spider and the flat. Now, if I, for example, wanted a spider that was set up for 12 thousandths, what I need to be able to do is put a 12 thousandths feeler gauge underneath this spider tip while I'm holding these three tips firmly on the flat. This is set up for a little bit more than 12 thousandths. The 12 thousandths feeler gauge slides under it quite loosely. To adjust the spider, you use a stone. I'll just put the stone here, and in order to take some set out of it, I'll take a little bit of length off of the two short legs there, just by grinding back and forth on the stone. And then I'll check the adjustment on it with the 12 thousandths feeler gauge. Well, I actually took too much off of that, just a little bit. In order to adjust it so where there's a little bit more set on it, I actually take material off of this end because this is a short leg and this is a long leg. If I take 1/1000th of an inch off of here, it actually changes the setting of the spider by 2 thousandths. And now the feeler gauge just fits snugly under that tip of the spider. And so this spider is now adjusted to 12 thousandths set, and we're done adjusting that spider. Okay, what I'm going to talk about here now is cutting a saw off. There's several different situations where you might want to cut a saw off. For example, if you have a broken saw with a ragged end, you want to cut it off to square that up, and then you'll need to repunch it. Or in this particular instance, what I'm doing is taking a 5.5 foot saw and cutting it down to a 4.5 foot saw by cutting one raker and the end teeth off so that I leave cutter teeth at the end. I'll cut that section off of each end, which will shorten it up to a 4.5 foot saw. So what I'll do is actually lay the saw on a straight edge like this so that the ends of the saw are on the line. You notice with a curved saw like this, the center of the saw is actually away from the curved line. What I want to do is make sure that the cut that I make across the saw is perpendicular to the axis of the saw, so that when you put the handle on it, you'll be able to sight down the handle if you're doing falling and use that as a gunning sight. So to mark the saw, I'll just take the square, lay it up against the table, and make a mark just about in the center of that gullet there, so that this mark is perpendicular. And then I'll put on goggles and ear protection because this is quite loud. My gloves. Now I've got a box here to support this, the saw, so it's flat on the saw table here. I'll clamp the saw in the vise. Check to see that it's lined up properly, and then go ahead and saw the saw off. Now that I've cut the one end of the saw off, I'll flip the saw over and cut the other end off that I had previously marked the same way. Just check, make sure I've got it lined up. Make sure that it's square, tighten it down. And here we go. Okay, now that I've got the saw cut off, what I need to do is take these burrs off the end, which I'll do over in a grindstone, and then I'll come back and we'll mark it for punching holes in it. Okay, the next thing to do is to actually punch a hole in the saw, and what I've done is build a hole punch out of the ends of a saw that I actually cut off of a saw, just very similar to what I just now did. And to locate where I want to put the hole, I'll actually take the end of a saw and I'll get my distance lined up using the existing hole. I'll put a mark there, and I know I want the hole about here. So now what I've done, I'll set the gauge up over the mark that I put on there. I'll clamp it with a pair of vice grips. And then this is the tool that I actually use to punch the hole with. Okay, once I've got my guide set up, I'll go ahead and put gloves on, because the next thing I'm going to be doing is hitting this thing with a hammer. And I need to lay this end of the saw flat on the anvil. Come up a little bit. And with the punch, which is this is actually a 5/16 inch pin punch, which is just a slightly amount smaller than the diameter of the hole that's in the guide. And I'll take a hammer, it's a 3.5, or this says 4-pound hammer, and give it a good strike with the hammer. If I don't hit the punch quite hard enough, the hammer will actually bounce back. If I hit it just right, the hammer will essentially fall dead, just like a dead blow hammer. And we should punch that slug right out. Okay, that punched the hole. Now getting the punch out sometimes is kind of interesting. Okay, that came out pretty well. I actually didn't punch the slug clear out. You can see that the slug is still in there. So now I need to get rid of that slug, and to do that, I actually put the slug over one of the holes here, take a big spike, put it down on the slug, and then it should just come out fairly easily. Okay. And there we have a hole. I want to talk now a little bit about saw patterns, tooth patterns, and things to look for when you're purchasing a saw, especially a used one. This particular saw here is a felling pattern. The characteristics of a falling saw are that it has a curved back, making it thinner from toothed edge to back, making it lighter, easier to use. This is a 4-peg and raker saw. It's got 4 cutter teeth for each raker. One of the characteristics of the older saws, the better made saws, is that they are thinner on the back than they are on the toothed edge, making it so that the saw won't bind if the kerf is closing up behind the saw. This next saw that I'll show you, this is a bucking pattern. Essentially the same saw as the falling pattern, with the exception that it's a little bit thicker metal and it's quite a bit thicker from the gullet to the back, because the back itself is straight. This is pretty characteristic of bucking saws. They're heavier, making it better for the bucking process, because the weight of the saw is used to facilitate the sawing action. This next saw is a falling pattern, also known as a ribbon saw. The primary differences and characteristics between this saw and the two that we've just looked at is that it's called a perforated lance tooth. Each pair of teeth has a bridge between them, which is used for stiffening the tooth so it doesn't vibrate as it goes through the wood. You want your teeth following each other very closely, and so the stiffness that's afforded by the bridge makes that a lot better. This next saw is a one-person pattern. The saws that I've shown you so far are 2-person, although each can be used by one person, but they're easier to use with 2 people. The characteristics of this particular saw is that it's asymmetric. You notice that it's much deeper from tooth to back on the handle end than it is on the off end. This particular saw has what's called a stinger handle or a helper handle on it, so that when a person is using it, you can actually use 2 hands on the saw. If you have 2 people who are wanting to use the saw, you can take this handle off and place it in the hole down here at the other end of the saw, and then you have a helper handle so that 2 people can use it. This particular saw has 2 cutter teeth per raker, which is more characteristic of saws built for hardwoods or frozen woods, often used in the Midwest and East Coast woods. Okay, that's a basic overshot of the saw shapes and patterns. Now I want to talk just a little bit about characteristics to look for when buying a used saw. This saw here is a good example of a bad saw. It's a bucking pattern, but you'll see that it's extremely rusty with significant pitting. The surface is very rough, and one of the problems with pitting is that you actually damage the structure of the teeth so that you can break teeth off when you're setting it. When you're looking to purchase a saw, avoid saws that have a lot of pitting on it like this. Other things to look for when purchasing a saw are your tooth length. You want a tooth that has quite a bit of length on it, at least an inch and a quarter long, because a longer tooth like that will give you more filings for your saw. Other things to look for are broken teeth. If you have 1 or 2 broken teeth in a saw, that's not particularly significant, especially if they're towards the end of the saw. But if it has a lot of them, especially if you have a number of broken raker teeth, then definitely avoid a saw like that unless you want to use it for a painter. One single broken tooth like this really is not going to have a whole lot of significance in how the saw cuts. And it can be adjusted for in how you adjust the height of the adjacent rakers if you do have a broken tooth on it. As I mentioned, the older saws, the better made saws, are taper ground. That's another characteristic that can be used to determine whether or not a used saw is of good quality, is you can, by looking at the end of the saw, here if you just look end on, you can often see whether or not a saw is tapered. If it's a flat ground saw, I would steer clear of it, because those are generally not as good a steel in them.